Okay, welcome everyone. I'm David Rammel, editor of Virtualization Cloud Review, here to welcome you to our Managing and Securing End User Computing Summit, brought to you by Nutanix. Our editorial staffs have worked hard to get some of the best independent topic experts for this event, so we really hope you enjoy it. And before we start today's three-session event, we do have some announcements. First, it's being recorded and will be available for future viewing. You'll soon receive an email when that replay is available. Also, each of today's three sessions will be followed by a 5 to 10 minute Q&A, so please be sure to put your questions into the Q&A area of your console as they come up. And during today's third session, we will be giving away a 256 gigabyte Surface Pro 8. You must be present to win, so be sure to stay on for the entire event. Finally, we do have resources from Nutanix available on the console right now, so please check those out. It's because of Nutanix underwriting this content that we can be in this summit, so we thank them for supporting the community and ask you to check out those resources so we can begin more events in the future. Now on to the first session of today's summit. Top Enterprise EUC Security Concerns and Best Practices. This session features Brian Posey. He's a freelance technology author and 20-time Microsoft MVP. Throughout his career, Brian has written or contributed to dozens of IT books, created numerous full-length video training courses, and published thousands of blog posts on a variety of IT and space-related topics. Many of those blog posts can be found in his Posey's Tips and Tricks column or in his new Posey's Moonshot column, where he posts fascinating updates about his commercial astronaut training. Brian, it's great to have you here. Please take it away.
Hey, thank you so much, David. So today I'm going to be talking all about end-user computing best practices, particularly as they apply to security, but not everything I'm going to be talking about is security-related. I also want to give you some general best practices for end-user computing. Now, it might seem kind of weird, being that this is the End-User Computing Summit, but the very first thing that I want to do is talk about what is end-user computing. I know that seems like such a basic question, but I want to make sure that we're on the same page, because end-user computing is one of those things that's like so many other things in IT, in that the community doesn't necessarily seem to agree on a definition. The term end-user computing has, at least in some ways, kind of lost its meaning over time. Because as I was preparing for this presentation, I just wanted to make sure I was on the same page as everybody else, and I did a search on end-user computing, and what I found was that there were about 1 million definitions, and even though there was a little bit of overlap between some of those definitions, some were way out in left field. And as a matter of fact, if you were to go out and Google right now, what is end-user computing, the very first result that you get, and this one totally surprised me if I'm to be totally honest with you, but the very first result that you get is codeless development or low-code development. In my mind, I always viewed end-user computing as virtual desktop infrastructure, or VDI as it's often called, or desktop as a service / cloud desktops. That's what I tend to think of end-user computing as being, and that's the way that I'm going to focus on the topic for the purposes of this presentation. Some of the other ways that the term is used is to refer to remote access. I've even seen bring your own device referred to as end-user computing, and even web applications. Not too sure about that one, but the term does get used. I'm not sure what's up with that. So before I really get into the meat of the presentation, there's one other thing that I need to talk about, and this one might also seem bizarre given the context of the presentation, but it's the question of, do you even need virtual desktops? And when I say virtual desktops, I mean virtual desktops and or cloud-hosted virtual desktops. But do you even need it? Now, I'm sure that this probably isn't a question that a lot of people want to hear, but I feel like it's an important question to ask, especially if you don't already have something in place. So what are the alternatives? Well, of course, local desktops, that's the obvious one. But another option is to do remote applications, or remote apps as they're sometimes referred to. A remote application has a lot of similarities with virtual desktops. It uses a lot of the same technologies. But the difference is that rather than hosting the entire virtual desktop, you're only hosting individual applications. And those applications, even though they're running remotely, They're accessible on a user's local desktop, and they run as though they were local applications. I'll show you an example of that in just 1 second. Before I do, there's 2 things I need to quickly mention. First of all, Microsoft actually had a remote app solution, but that reached end of life a few years back. Even so, there are some other solutions out there that exist. I'm not here to promote those solutions or to tell you you should or shouldn't use remote apps. I only want to present this as one option in context of the greater picture. The other thing that I need to point out before I show you what this looks like is that I didn't have time when I was preparing this presentation to go set up a remote app environment and get a screenshot. So rather than do that, what I did was I went through my inventory of everything that I've ever written. I did a search on remote app, and I found an article that I wrote way back when. It dated all the way back to 2008. But I pulled a screenshot from that article. Even though the screen capture is grossly outdated, it at least gives you a picture of what remote apps are. So let's go ahead and take a look. So here's what it looks like. And you can see that I've got a Windows desktop and I've got the calculator open. So the Windows desktop is local. The calculator, on the other hand, is a remote application. And if you look closely, I know it's a little bit small, but if you look closely, it appears just like any other application that would be running on Windows. The only difference is it's running remotely instead of running locally on this machine. The only real clue is down in the taskbar. You'll notice the word remote just to the right of the application name. One other thing that you might notice, if you look on the right side of the screen, you'll notice an RDP icon. Now, RDP is oftentimes used to access virtual desktops, but in this case, that icon is actually used to launch a remote application. At any rate, this is a little bit beyond the scope of this presentation, but I at least wanted to put that out there as an option because as you go and search on various security best practices, there are a lot of people who believe that you should be doing remote apps rather than remote desktops. As I said, I'm not really here to take one side or the other, but I wanted to present that as an option. So let's get back to the topic at hand, and that is end-user computing. So one of the big questions that so often comes up is end-user computing a silver bullet? And by silver bullet, what I mean is a solution that addresses most, if not all, security concerns and just magically solves all of your security problems. Well, the very short answer to that is no, it isn't a security silver bullet. The longer answer to that is no, but. The reason why I say that is because there was a time when virtual desktops did solve the vast majority of security problems. And sadly, that's no longer the case. But because virtual desktops were so well known for security at one point, they've kind of gotten a reputation for being a lot more secure than local desktops. And in some ways, they still are. Now, that's not to say that virtual desktops or cloud-hosted virtual desktops are insecure. You can make them as secure as you need them to be. And that's what this presentation is all about, is to give you some best practices that you can take back to your own environments and apply in order to make your virtual desktops or cloud-hosted virtual desktops a lot more secure. So let's go back to something that I said just a moment ago. I mentioned that at one time, virtual desktops did address the vast majority of the security problems that existed. So why is that? Well, way back when, longer ago than I even cared to think about, I worked as a CIO for a chain of hospitals and healthcare facilities. And a few years after I left that particular organization, I had another healthcare facility in a different part of the country call me and ask me if I would do a consulting job for them. The scope of that project isn't really important, but what is important is that when I got out there, they had a setup that I had never seen before. Now remember, this was a long time ago. What they were running is instead of normal Windows desktops, they had what looked like Windows desktops, except those desktops were running Windows CE. Now, for anybody who's not familiar with Windows CE, it was an extremely lightweight operating system that was specifically designed to run on mobile processors. I believe it ran on RISC systems. And Windows CE was primarily used on handheld devices. But this was the first time I'd ever seen what looked like a desktop computer running Windows CE. And those Windows CE machines connected to back-end virtual desktops. And, certainly I'd seen Windows CE at that point, but I'd never seen a CE machine that looked like a desktop computer. And I asked the admin why they were doing that as opposed to just running a normal Windows environment. And what he told me was that this eliminated a lot of the security risks. Because these particular machines, which were essentially zero clients, had no removable media, no USB ports. There wasn't a way for users to copy any of the data off to removable media and take it out of the organization. Similarly, there also wasn't a way for users to install anything that they might have brought in on their own, because these machines didn't have internet access. So essentially it was completely cut off from everything, and it was an ultra-secure environment. Now, things have obviously changed a lot since then, and virtual desktops and cloud-hosted virtual desktops have become a lot more capable, and sadly some of the security that we had back in the day no longer exist. Part of that isn't so much because virtual desktops have become less secure as much as that malware and other types of attacks have become increasingly sophisticated over the years. But I'm getting a little bit ahead of myself. Now, as I get into these various security best practices, there's one very important thing that I want you to remember, and that is that security is something of a balancing act. And this is perhaps nowhere is this more true than when we start talking about virtual desktops and cloud-hosted virtual desktops. You have to balance security with usability and performance. So what do I mean by that? Well, I've got a friend who used to always say that if you wanted to make a machine truly secure, then what you do is unplug it, stick it in a safe, drop the safe in the ocean, and let it sink to the bottom. At that point, it's completely secure. It's not connected to anything, not even to power. Nobody can get to it to do anything, so it's totally secure, but it's absolutely unusable at that point. So security and usability have to be balanced with one another. Now, when it comes to performance, you have to remember that virtual desktops and cloud-hosted virtual desktops share resources with other virtual machines. So just like virtual servers, you have to be careful about how you're allocating those resources and how those resources are being used so that you don't have a negative performance impact by some of the things that you're implementing. So you got to balance security, performance, and usability with one another to get the best possible balance. And that balance is going to be different for every organization. So let's go ahead and get into the best practices. Now, the very first best practice is to know your responsibilities. Now, this one doesn't apply so much to VDI because in a VDI environment, you're typically responsible for everything. But when it comes to cloud-hosted virtual desktops, all of the providers that I know of use what's called a shared responsibility model, meaning that the provider is responsible for maintaining certain aspects of the virtual desktop, the cloud-hosted virtual desktop infrastructure, and subscribers are responsible for maintaining other things. And typically, the providers will give you a chart similar to the one that you see on screen outlining what those responsibilities are. So this one came from Microsoft. And if you take a look at this chart, you can see that subscribers are responsible for identity, user devices, application security, session host OS, deployment configuration, and network controls, whereas Microsoft maintains responsibility for the virtualization control plane, the physical hosts, the physical network, and the physical data center where those virtual desktops are running in the cloud. So in other words, you're responsible for keeping your own virtual desktop secure and for maintaining the security of your own data. So having said that, the next thing that I want to look at is what are the threats to security? Now, this obviously isn't a comprehensive list. I'm not even sure I could make a comprehensive list because there are such a variety of threats out there. But I wanted to touch on some of the bigger ones. So some of the things that can come into play are compromised end-user devices. These are the physical devices that users are using to connect to your virtual desktop or cloud-hosted virtual desktop environments. Malware infections on the virtual desktop itself. Missing security patches, hypervisor attacks, human error, and data exfiltration. So I'll go into most of these at least a little bit. Starting with compromised end-user devices. So the idea here is that the users have to use some kind of physical device, whatever it is, to connect to their virtual desktop. And that device, assuming that it's outside of the organization's control, may or may not be compromised. It may have malware on it. It may have rogue applications on it. You don't really know a lot about how that device is maintained and what its current state of health is. So that's a problem. There are actually some consultants out there who believe that the vast majority of all end-user devices have been compromised. Sadly, I couldn't find any reliable statistics to back that up, so I didn't want to put that out there as a fact or anything. But what I think we can all agree on is that at least some of the end-user devices are indeed compromised. We just don't truly know the extent to which that holds true. Interestingly, users might not even know that their devices have been compromised, or the users may know that the device has been compromised but not really think that it's a problem. And the big example that I'll give you of that is Windows profiles on multi-user systems. So if you think about Windows 10 Home Edition, it allows home users to set up multiple profiles so that each person in their household can have their own logon. So the user powers up the machine, they click on the icon next to their name, they enter their password, and then they're taken into their own user profile. So there are a couple of different ways of looking at that particular feature. One is that because everybody operates in their own separate profile environment, it's possible for one person in a household to do something to a machine that the others are totally unaware of, because that change might be isolated to their own profile, or at least have the appearance of being isolated to their own profile. Another thing is that these profiles can sometimes give people a false sense of security. There's somebody that I know really well. I don't want to say names or anything, but there's somebody I know who has a machine, and I was visiting them not too long ago and asked if I could just sign on to check something really quickly. And they made an offhanded comment about that their profile was safe, and I asked them what they meant by that, and they said that somebody else in their household had gotten a hold of some malware, and that person's profile was chock full of viruses or what have you, whereas the person I was talking to's profile was clean. So this particular person knew that that machine had been compromised, but they assumed that the compromised machine was no big deal because there was no visible evidence on their own profile of that compromise being a problem. So these are the types of things that you have to think about, particularly with people working from home, accessing your end-user computing environments from their own personal devices. So let's talk about malware infections. At one time, virtual desktops pretty well solved the malware problem. And the main reason, well, there were two reasons for this. One was that malware wasn't as sophisticated back then as it is today. The other was because of something known as persistence. Now, the idea behind persistence, for anybody who's not familiar with it, is that you can have persistent virtual desktops or non-persistent virtual desktops. A non-persistent virtual desktop is a virtual desktop that resets itself to a pristine state at the end of every session. So in other words, a user logs on, they do whatever it is they need to do in the virtual desktop environment, they sign out, and at that point, the backend system completely resets that virtual desktop so that it's like a brand new machine. Nothing that that user did sticks. So if you think about the way that malware used to be, malware used to focus on infecting a local machine. So if that local machine, the virtual desktop in this case, was reset to a pristine state at the end of every session, well, then malware really wasn't much of a problem. Today, that's no longer the case. Part of that is because of persistent virtual desktops, where user information is retained from one session to another. But the bigger problem is that because a lot of modern ransomware spreads beyond the system where it was initiated. Ransomware will very often seek out network shares, cloud applications, and anything else that it possibly can, with the goal of exfiltrating data and or encrypting data. So all of that is to say that modern virtual desktops, at least when compared with physical desktops, don't really offer a huge advantage with regard to malware protection. Another security issue is missing patches. Now, I don't want to go into this one in any kind of depth because we all know about security patches. But the point being is that just because you're working on a virtual machine doesn't mean that you no longer have to worry about patch management. Unless, of course, you happen to be using a cloud-hosted solution where the provider handles all of the patching for you. That's the big exception. But if you're maintaining your own images or your own desktops, then patching is something that you still need to take very seriously. Because remember, security patches address known vulnerabilities. And if a vulnerability is known, that means that both the good guys and the bad guys know that that vulnerability exists. And so there are probably those within the hacker community who are working to actively exploit that vulnerability. So it's extremely important to make sure that all of the applicable patches get installed on your virtual desktops, regardless of whether they're in the cloud, on premises, or whatever. So hypervisor attacks, and I probably should have called this one host attacks rather than hypervisor attacks. These are a lot less common because they represent a more sophisticated type of attack, but they're plausible nonetheless, so it is something that you should at least be thinking about. The idea behind this type of attack is that an attacker takes over the host where the virtual desktops are running, and then they begin replacing the virtual desktops with virtual desktops of their own. They can do this by replacing the virtual machines, or what I've also heard of being done is an attacker going in and altering the gold image that's used to generate those virtual machines. So there's no immediate effect on the virtual machines themselves, but the next time the virtual machines are generated from that image, then the virtual machines become compromised because the image that they were created from is compromised. So the next thing to think about is what can you do about these threats? I mean, really, that's what this presentation is all about, is looking at some security best practices that you can use as countermeasures to address these and other threats. Well, one of the first things that I recommend is not limiting the focus of your security efforts, particularly if you're in a VDI environment where you're hosting your virtual desktops on premises. What I would recommend doing is not focusing solely on the virtual desktops, but focusing rather on every aspect of the entire VDI infrastructure. Because any one of those points, any one of those infrastructure components can potentially become a security vulnerability that an attacker might be able to exploit in order to take over your VDI environment. So focus on securing every component that makes up your VDI infrastructure. I'm talking about things like the endpoint devices, the virtual desktops themselves, the host operating system, the connection broker, and whatever other infrastructure components you might have in place. Now, as I get into talking about the various security best practices, one thing that I need to be sure and point out is that security best practices can vary widely depending on the vendor and the operating systems that are being used. So I'm trying to structure these best practices as being general in nature and try to make them things that apply as widely to as many system types as possible. Just keep in mind that not every best practice that I'm going to cover applies equally to every situation. There are a lot of situations where you may have to make a judgment call because a particular best practice might not necessarily meet your organization's own unique needs, or because the vendor who provides the software that you're using has a completely different best practice, in which case I would recommend going with whatever it is that the vendor tells you. So, first thing that I want to talk about is something I already touched on a little bit, and that is desktop persistence. Now remember, persistence is the idea that a session can be persistent persistence is based on the idea that you can have it so that a user's desktop persists from one session to the next, or non-persistence is the idea that you can blank a virtual desktop at the end of each session, wiping it back to a clean state. So my recommendation would be to use non-persistent virtual desktops whenever possible. There are sometimes business use cases for persistent virtual desktops, and in those cases it's fine to make persistent virtual desktops. But the idea is that you should make persistent virtual desktops the exception, not the rule. And I'll show you an example later on of why that is the case. And while we're on the subject of persistence, I think that we also have to talk about profiles, particularly for Windows environments. Now, normally when you create virtual desktops, whether that's in a VDI environment or in a cloud-hosted environment, those virtual desktops by default will typically use roaming profiles. These are the same types of profiles that we use on our local systems most of the time. The idea being that users can change anything that they're allowed to change. They can change their wallpaper, they can rearrange icons, they can pretty well do whatever they want within a reason. A mandatory profile, on the other hand, is very similar to a roaming profile. The profile file itself just has a different extension. But the extension, which is .man, by the way, tells Windows that the user shouldn't be allowed to make any kind of changes to the profile. So during the user session, the user can do all the same things that they would normally do. They can rearrange icons, they can change wallpapers, they can do whatever they want. But at the end of their session, all those changes go away and they're back to whatever profile you set up for them. Now, why do I recommend using mandatory profiles in virtual desktop or cloud virtual desktop environments? Well, again, it's not one of those things that really fits for every situation, but it is one of those things that I recommend using more often than not. And the reason for this is simple. Every once in a while, you may find that a user ends up opening a malicious email or visiting a malicious website, and even if those particular sites don't unleash a devastating attack, they can do things that might not necessarily be in your best interest. I'm talking about things like installing unwanted browser toolbars or making other changes. I've seen items added to control panels, stuff like that. Well, if you've decided to use mandatory profiles, then if a user happens to do something like that that causes a browser toolbar to be installed or the control panel to be altered or some other low-level change being made that makes it easier for a future attack to take place, those changes get wiped out at the end of the user's session. So you don't have to worry about that being a persistent problem for you. So if you look at the slide, you can see a description of what a mandatory profile is, which I've pretty well already discussed. But down at the bottom, highlighted in yellow, it says mandatory user profiles are useful when standardization is important. And typically that's the case on kiosk devices and in educational settings and things like that. But I would definitely add virtual desktops and cloud-hosted virtual desktops to the list. Not so much for the need for standardization as much as the need for avoiding tampering. So another best practice is to consider whether or not you want to block the clipboard from your virtual machines or cloud-hosted virtual machines. Now, I'll tell you straight up that depending on who you talk to, this one may or may not be a best practice. Me personally, I'm on the fence about blocking the clipboard. I think that it really depends on the individual organization and business use cases. There are advantages to blocking the clipboard and there are disadvantages. So let's just go ahead and talk about a few of those. As I mentioned, there are quite a few security consultants out there that recommend blocking the clipboard as a security mechanism, or as a security measure, rather. But having said that, even though blocking the clipboard might act as a deterrent, it probably isn't going to stop a determined attacker, at least not by itself. Blocking the clipboard can be part of a defense in-depth solution, but just blocking the clipboard as your primary security mechanism probably isn't going to do a whole lot to stop an attack. And at the same time, it can also make it more difficult for a user to do their jobs. But at the same time, one of the big advantages to blocking the clipboard is that it can help with preventing data exfiltration. Data exfiltration refers to the practice of a user stealing your data and copying that data outside of where it's intended to be used, maybe to removable media, maybe posting it to a website. Who knows what a user is going to do with your data. And blocking the clipboard is one way of helping to put a halt to that. It keeps the user from being able to just copy and paste something. Okay, VDI and malware. And I've already talked about this quite a bit, but I want to go into the whole malware thing just a little bit deeper, because there are several different ways in which malware can come into play with regard to virtual desktops or cloud-hosted virtual desktops. Think about some of the ways that malware can make it into these types of environments. Probably the most common is that a user opens an email message, they click on a malicious link, and then that malicious link ends up releasing ransomware or some other type of malware. Now, let's think about what happens in a virtual desktop or cloud-hosted virtual desktop environment when that happens. The desktop itself, assuming that it's set to be non-persistent and you've got mandatory user profiles in place, the desktop will more than likely be unharmed. But remember what I said earlier about that ransomware has become increasingly sophisticated over the years. Just because the desktop itself is going to be resilient against that type of attack doesn't mean that the other resources on your network are going to be equally resilient, because that ransomware isn't just going to attack the local desktop. It's going to go out and look for other things that it can attack, whether that be your SaaS applications and the data within them, or your network shares and the files that the user has access to. So the point being that the malware attack isn't just isolated to that one virtual desktop. You have to think about how that can spread beyond the virtual desktop. Another way that malware comes into play is that a user's physical device that they're using to access your virtual desktop is infected. And again, there are a lot of different types of malware out there, but let's suppose for a moment that the user's physical device is infected with a keylogger. Well, what that means is that when the user opens up their virtual desktop session and they enter their username and password, that username and password gets copied to a file and sent to whoever installed the keylogger. And then at that point, that person has the user's credentials. So the best countermeasure against that sort of attack is to require multi-factor authentication. Then the third one that's on the list is another situation in which the user's physical device is infected, but this time, rather than being infected with a keylogger, it's infected with remote control software. And in that particular case, the hacker doesn't really have to do anything. All they have to do is just wait for the user to sign into the virtual desktop environment, and they don't even need the user's credentials because they have remote control capabilities over that user's machine. So at that point, once the user has logged into the virtual desktop environment, they can just hijack the session and do whatever they want. And typically, they're not going to do this on the first time they see the user open the session. They're going to spend some time watching what the user does and getting a feel for what the virtual desktop environment is like and what the user is able to do, what they can't do, maybe what their job function is, because that will give them a sense of what types of resources they can penetrate. So all of that to say is that malware is a very real threat even in virtual desktop or cloud virtual desktop environments. So a few quick things to consider. One, it's a good idea to run malware prevention software on all of your virtual desktops, regardless of whether those are hosted on premises or in the cloud, because ransomware can spread to other systems. Also, and I think I've mentioned this a couple of times already, user profiles can become infected, even if you're using non-persistent virtual desktops. That's one of the reasons why I recommend so strongly using mandatory profiles, assuming that your business use case allows for doing that. Now, another best practice is to be careful about the types of advice that you follow regarding the use of anti-malware software. Now, using anti-malware software is important. It's a good thing to do. It's something you absolutely should be doing. But whenever you visit a random website for best practices regarding malware software or anti-malware software in your virtual desktop environment, it's really, really important not to just blindly follow the advice that you're given. Not necessarily because it might be bad advice, but rather because the advice might be slanted toward a different goal than what your goal is. And what I've got on the slide is a perfect example of that. So let's just take a second and go through this. And I know the type is small on here, so I'll go ahead and read this. This came from a blog site, and again, I'm not saying that whoever wrote this is giving bad advice, just that you have to consider what the advice is meant to achieve. So it says, among the suggestions from VMware to ensure the best virtual desktop experience, users should, and then there are several bullet points, limit real-time scanning to local drives only, run virus scan on master images before putting them into production. Now, from a security standpoint, the first bullet point might be a little bit questionable, but okay, we'll go with it. Second bullet point sounds right on track. But here's where things go off the rails a little bit. The third bullet point is remove any unnecessary antivirus actions or processes from the desktop startup or login routines. Then we have disable heuristic scanning, and then disable auto updates of antivirus software. Now, in my mind, this violates any number of security best practices. But remember what I said a moment ago. You have to think about what the recommendations are really meant to achieve. The particular site that I pulled this off of wasn't security-oriented. Instead, it was talking about how to get the best performance out of a virtual desktop, particularly in environments where performance is already suffering and maybe you need to do some fine-tuning to improve performance. So these recommendations aren't necessarily going to provide you with the best security. In fact, I would argue that they're counterproductive from a security standpoint, but rather they're designed to help boost virtual desktop performance. So all of this is to say, just be careful about the advice that you follow with regard to virtual desktop security, particularly when it comes to anti-malware. So the next thing that comes into play is that remember malware itself comes in several different forms, and there is some overlap between these, and I've touched on a lot of these already. There's ransomware. I think everybody probably knows what that is. Then we have fileless malware, human-operated malware, and spyware. So let's talk about fileless malware for a moment. Now, fileless malware is one of those things that really I could do an entire session on, and as a matter of fact, I actually have. I've got a few screen captures on some of the slides that are coming up, and these were taken from a live presentation that I did one time where I actually did a fileless malware attack in front of an audience just to show how it works. Now, obviously, we don't have time for something like that, nor do I have the environment set up to do a demo of that sort in the middle of this presentation. But I want to show you a few of the high points just to kind of give you a sense of what fileless malware is really all about and why your virtual desktops can be vulnerable to this sort of thing. So here's what a fileless malware attack looks like. So in the bottom left corner of the screen, we have the attacker's machine. So the attacker then runs some commands on the victim's machine, as designated by that arrow pointing from the attacker to the victim. So this attack is something that happens once that machine has already been compromised. So the big caveat to this whole process that you're about to see is that the attacker has to have access to the victim's machine already before they can launch this type of attack. This isn't something that an attacker is going to do just to initially gain access to the machine. They have to already have access. So the attacker communicates with the victim's machine, and they launch the attack from there. They then signal the victim's machine to go out to a malicious web server and download code from that web server. And then once that code has been downloaded, then the attacker can use that code to do whatever it is that they're trying to do. So let's take a look at a couple of quick examples of how this works. So what you see in this slide is a screen capture that I took from an IIS server running on Windows. So this is the web server that comes with Windows Server. And the File Explorer window that you see in the foreground is pointing to the www root folder. The www root folder is the default location for storing hosted web files on IIS. And you'll notice that I've created a file called eviltrojan.exe. That's my malicious payload. In reality, it's not actually malicious, but I didn't want to use something malicious in my own lab environment if I could keep from it. So for the purposes of that demo, this eviltrojan.exe file is the file that the attacker ultimately wants to run on the victim's machine. So they set up a malicious web server, and they put this file in the set of files that's hosted by that web server. So the next step, as I mentioned, is that the attacker establishes a session with the victim's machine. Then they begin launching an attack against that machine. Now, in this case, I used PowerShell. In reality, the attacker can use anything that they want. The reason I chose to use PowerShell is because it's one of those things that's really well documented, and it's actually part of Windows, so it's something that everybody's got. So let's take a look at what we're doing here. We've got invoke command -computer name demodc -script block. So demodc is the name of the machine that I'm running the attack against. And everything that falls within the script block are commands that are being redirected to that demodc machine. So these are the commands that are going to be run directly on the victim machine. And remember, the attacker runs these commands on their own machine, and those commands get redirected to the victim's machine. So the first one is a new item -path :/-name files item type directory. So this particular command creates a folder called files on the victim's machine. The next command, invoke web request -URI, and then we've got a URL pointing to that evil Trojan file, and then -out file :/files/explorer.exe. So what this command does is it instructs the victim machine to go out and download that evil Trojan file from the rogue web server, and then store that file in the :/files folder that was just created. But it's changing the name of the file from evil Trojan to explorer.exe, something totally benign that's part of Windows that hopefully won't raise too many red flags. And then the last command was invoke expression -command cmd.exe/c and then :/files/explorer.exe. So what this command does is it opens a command prompt environment, which is different from PowerShell, and it launches the explorer.exe file. So the end result, which you can see right here, is that the evil Trojan file has indeed been installed on the victim's machine, renamed, and I don't have a screen capture of it, but it can also be executed using that script block that I just showed you. So all of that is to show that fileless malware attacks can be directed against any Windows machine. It doesn't matter if it's a local machine, a VDI machine, a cloud-hosted virtual machine. This type of attack is something that any hacker can do once they've gained access to a machine. And it's nothing that's overly difficult to do. I mean, I just showed you the high points of how it works. But as I mentioned, there are some other types of malware that you need to be thinking about. One of those is human-operated malware, which is a variation of what I just showed you, except that the attacker is a little bit more involved in the attack process. Another one is spyware. I'm talking about things like rootkits, keyloggers, which I mentioned a moment ago, which are often used for stealing passwords. So let's move on from talking about malware and talk about operating system images, because in VDI environments and cloud-hosted virtual desktop environments, the operating system that runs on the virtual desktop is almost always generated from operating system images. Because by using those images, you can deploy new virtual desktops in an automated fashion, and it can be done in a uniform way so that every virtual desktop that's generated is identical. So that helps a lot with management. But there are a lot of best practices with regard to maintaining these operating system images. First off, keep those operating system images in a secure location, because these are a favorite target for attackers. Also, carefully choose what you're going to include in those images. My philosophy is less is more. The smaller you can make those images, the less complicated you can make those images, the less opportunity that there is for that image to be exploited. Disable unnecessary services. Now, obviously, disabling Windows services that are normally started by default is one of those things that maybe you should, maybe you shouldn't be doing. But depending on the user's job function and what it is that they need to do, there may be services that you can disable. One that comes immediately to mind is the print spooler, because over the years there have been quite a few different attacks that have been launched against the print spooler service. And if the user has no need of printing from within a virtual desktop environment, then you can disable that particular service and eliminate one potential security weakness. And there may be other services that you can disable as well. Also, uninstall any unnecessary operating system features. We all know that the Windows operating system tends to be bloated, and that a default Windows configuration has all kinds of things that you may or may not need. There might be games that you can uninstall. There might be unused things like, I don't know, maybe an Ubuntu, I can't pronounce it now, a Linux session that you can get rid of. I mean, who knows what's going to be installed. So take a really frank look at your virtual desktop image and see what can be uninstalled without inhibiting a user's ability to do their job. Also, be sure and configure the local group policy. A lot of organizations will depend on domain-level group policies to provide security for their endpoint environments, and that's great. But every once in a while, and this is super rare, but I've seen situations in which a user can log on and for whatever reason the group policy fails to be applied, or something happens and causes the group policy to behave unexpectedly. So having a local group policy in place is something that you can fall back on in situations like that to make sure that those virtual desktops are secured. Also, it's a really simple thing, but make sure you scan the image for malware before you begin using it. Another best practice is don't include applications in the operating system image. It's better to maintain those applications separately. So that way they can be serviced independently, the operating system can be serviced independently, and that will make it a lot easier to provide updated operating system images as new patches become available. Also, create new operating system images on a regular basis. I know it can be a lot of work, but I think that it's important. And the way that I think of this is kind of the way that Las Vegas casinos do it. In a Las Vegas casino, the gaming tables have their materials swapped out on a regular basis. Maybe every 15 to 20 minutes, they will replace a deck of cards with a new one, or they'll replace a pair of dice with a new set. And the reason why they do that is that in the unlikely event that those cards or those dice have been compromised, then those are eliminated and replaced with brand new ones that are known to be clean, so that way damage from the compromised cards or the compromised dice can be limited. The same thing should happen with your operating system images. Replace those images on a regular basis so that if there is a problem with the image, you're getting rid of that as quickly as possible and replacing it with something that you know for a fact is good. Also, make sure that any images that you create have the latest security patches. I actually talked to somebody at, I won't name the place, but a major corporation that ran into a problem. And in all fairness, this was back in the days of Windows XP. But they went to do a deployment, and before they even had time to install any security patches, and we're talking about a matter of hours, some of the machines had already been compromised simply because they were vulnerable, because they were unpatched. So go ahead and install any security patches in your images ahead of time, so that way you've already got virtual desktops in a relatively current state the moment they're brought online. There may be some additional patches that you have to install at that point, but at least that image is as up to date as it can be. Another important one, don't allow users to have local admin access. Now, this is another one of those things that can be a point of contention in virtual desktop environments. But the idea behind this is that if you're preventing users from having local admin access, you're not allowing them to install any software or to run anything that they shouldn't. Now, some people will tell you that this is a moot point if you're using non-persistent virtual desktops and mandatory profiles, because everything gets reset at the end of the session anyway, so it doesn't matter if the user runs something. But remember, not all applications are, what's the word I'm looking for? There are rogue applications out there. A user could run a business application just as easily as they could run malware. So you don't want a user to be able to run anything that they're not authorized to run. And one of the best ways to do that is just to make sure that they don't have local admin access on the virtual desktop. And while you're at it, don't forget about browser security. That's one area that's sometimes overlooked when preparing virtual desktop images. And it looks like I'm getting pretty close to being out of time, but I'll go ahead and make this one final point. In your virtual desktop environment, pay attention to IP address ranges and firewall rules. The idea behind this is this. If your users are working exclusively from virtual desktops, then any requests that are going to your application servers or to your databases or anything like that should be coming from known IP address ranges. So you can put firewall rules in place that block traffic from any other location. So that way, if a user just happens to be coming in outside of your virtual desktop, then any request to those particular resources will be denied and logged so that it can be dealt with at a later time. So your network resources should only ever be accessed from machines that fall into a known address range, specifically the range that's used by your virtual desktops. And there may be some carve-outs for things like management servers or servers that run dependency services and things like that. But as a general rule, you should only allow access from your virtual desktops. But just because somebody is coming in from a virtual desktop doesn't mean that that particular session is legitimate. So there's always the possibility that a hacker could have hijacked a virtual desktop session and be coming in from somewhere else and not be who they claim to be. They could be impersonating one of your users. Now, that's one of those things that's really hard to guard against, but conditional access rules can help you with that sort of thing. Conditional access rules are essentially a collection of rules. They function kind of like if-then statements. So you're not just looking at, does a user have access to this particular resource? You can look at other conditionals or other conditions as well. For example, you can look at, where's the user geographically located? What time of day is it? And a number of other conditions. And look at a variety of conditions and use those conditions to make up or to make a decision as to whether or not the user should be granted access to that particular resource. So I believe I still have quite a few slides to go, but I'm going to go ahead and end it there because I want to save a few minutes here at the end to be able to take questions.
Okay. Well, great job, Brian. And we do have some questions in the Q&A console. I'd like to remind the audience they can send them in. We have a few more minutes to answer those, so let's get to them right now. First come, first served. The first question reads, what types of data can be detected with data loss prevention?
Okay, data loss prevention is definitely one of those things that you should be incorporating in your virtual desktop environment. I actually had a few slides on that at the end. When I talked about the threats to virtual desktop, I mentioned data exfiltration as one of those threats, and I talked about how the clipboard could be used for data exfiltration, but that's not the only thing that can be used. One of the more common vectors is a user just emailing data to themselves or to somebody else. So that's where data loss prevention comes into play, is that you can set up a data loss prevention filter, and that's something that comes with Microsoft 365, and it's available in certain other environments, and it does pattern matching. So it will actually look through outbound emails and things like that to see if any of the information in that outbound email matches patterns. It can look, for example, for patterns that match credit card numbers or social security numbers or pretty much any other types of data matching patterns that you might choose to set up. So it's a really great way of keeping data from making it out of your environment.
Okay. Next question reads, is hyperconverged infrastructure a requirement for virtual desktop environments?
No, it's not technically a requirement. You can host VDI on any hardware that you want within reason. But the reason why HCI is such a popular platform for VDI is because of uniformity. HCI environments allow you to scale by adding nodes, and each of those nodes is identical to one another. So if you know how much resources a particular virtual desktop typically consumes, you can figure out how many virtual desktops you'll be able to host on each node, and then you can expand capacity on an as-needed basis just by adding the number of nodes that will accommodate your known requirements for the number of virtual desktops that you need to add.
Okay. Next question reads, all things considered, do you recommend cloud desktops or virtual desktops?
I think it really comes down to your business use case. But beyond that, there are a few other things that you have to look at. Like, for example, if a business is a startup, they're probably not going to want to invest a huge amount of money in all of the infrastructure that it's going to take to host a VDI environment on premises. An organization like that would probably be better off just setting up a cloud virtual desktop subscription just because of the cost and the time that it would take to ramp up. But on the other hand, if an organization is super concerned about privacy and they want to keep everything within the walls of their own data center and they've already got everything that they need, then that's certainly an option for them. I don't know that one is necessarily better than the other, assuming that they're both well-maintained. It really just comes down to what's going to be a better fit for your own unique needs.
Okay, great. In a previous session related to this topic, an audience member asked, how do you optimize the OS for VDI? And since this is a security-related presentation, I was wondering, are there any security-related optimizations you can make to an OS for VDI?
Oh, absolutely. I could probably do a whole session on just that sort of thing. But local security policies is a big one. And also, like I had mentioned a few moments ago, browser security, because you need the browser to be hardened to the point that it can't be compromised. So there are any number of group policy settings within that local security policy that can be put into place to really lock down the browser. Also, I would strongly recommend using AppLocker within your virtual desktops. AppLocker can be used to whitelist certain applications, so that means that the user is only able to run applications that you've specifically authorized, and anything that falls outside of that whitelist is denied. Now, in all fairness, AppLocker can be a little bit tricky to set up, and there are some third-party programs that do the same thing, but that are a little more comprehensive and do a little bit better of a job. But if you don't have the budget for that, then I would recommend just spending some time and delving into AppLocker because they can go a long way toward keeping your environment safe.
Okay, great. Next question. Do you have any idea how much encryption degrades a typical VDI session performance?
That's a really hard one to answer because there are so many different types of encryption, and some have more overhead than others. But another thing that you have to consider is whether or not hardware-assisted encryption is being used. There are some network cards out there that will offload certain types of encryption, and that can really minimize the load on your VDI environment if that's being offloaded. So unfortunately, there's not an easy answer to that question.
Okay, great. Well, it looks like that's all the questions we have time for. So
David,
thanks again, Brian. Go ahead,
David,
Brian.
One quick thing that I would add to that particular question is that the encryption-related overhead isn't nearly as much of a factor as it used to be, because in the early days of VDI, CPUs had very limited capabilities, and encryption oftentimes used a lot of the capabilities that were available. but processing power has grown exponentially over the years, so encryption doesn't take nearly as big of a bite out of that as it used to.
Okay, well, thanks for adding that. And that's a wrap. Everyone stay tuned. We're going to take a short break and be back at the top of the hour for our second session of the day, EUC and BDI management and infrastructure best practices. So hang tight, check out those resources on your console provided by Nutanix, and we'll be right back.
Hi, everyone. Welcome to the second session of today's summit, Managing and Securing End User Computing. This event was organized by the hardworking folks at Redmond Magazine and Virtualization and Cloud Review, who have brought together some of the best independent experts on today's topic. Many thanks to our sponsor, enterprise cloud platform provider Nutanix, for making this event possible. And thanks to you for joining us. I'm John K. Waters, Editor-in-Chief of Application Development Trends in the Converged 360 group of 1105 Media, and I'll be your moderator for the second of our 3 information-packed sessions. But before we get started with this session, just a quick reminder that each of today's sessions is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way within the next few days. This session will be followed by a 5 to 10 minute Q&A. You can type your questions into the Q&A box at any time. Please feel free to add your questions as they occur to you throughout the summit. We'll do our best to get to all of them. Our sponsor, Nutanix, has provided some extra resources that can be found on the right-hand side of your screen. Please take a moment to check those out. And during our third session, one lucky attendee will be receiving a Microsoft Surface Pro 8. This beautiful tablet has a 13-inch touch screen, 16 gigs of memory, and a solid-state drive. But you must be present to win, so stick with us. Now let's get started with our second session, EUC and VDI Management and Infrastructure Best Practices. For this session, we've called on senior analyst and writer Tom Fenton. Tom has a wealth of hands-on IT experience in a variety of technologies, which he earned over 25 years in the industry. His focus over the past 15 years has been on virtualization and storage. He worked at VMware in staff and senior level positions, and he served as a senior validation engineer with the Tenneho Group. I can never pronounce that. With the Tenneho Group, where he headed the validation service lab and was instrumental in starting its vSphere virtual volumes practice. Tom wrote the first training course for Horizon, VMware's virtual desktop product, and he is a frequent contributor to Virtualization and Cloud Review and StorageReview.com. He's one of our most popular presenters and one of my favorite podcast guests. Take it away, Tom.
Hey, thank you for the kind words there, John. I really appreciate it. Like John said, I've been around the industry for quite a while. And before we get going, I have to say that I've been involved with remote working technologies for 15, maybe 20 years now. And I've actually been working remotely for the last 15 years. But these last 2 years have just been transformative. We've learned a lot of lessons in that time. The number of corporations with having remote workers has just grown exponentially. Like I said, over the last 15 years, I've seen many practices that work well and many that haven't. And I'm going to go ahead and share my experience with you today on that. Kind of as a side note, I will not be going over things like the sizing of desktops or other information, because that's readily available and it really depends on vendors. So you instead of going over those things, I'm going to go over some other things that I think you might find interesting. So let's go ahead and get started. Oh, I do have to go mention that I did publish my first book, ESXi on ARM, and that was published by A-Press, and I just noticed that we had 4.5 thousand copies sold, so that's really exciting for me. So let's go ahead and get going here. As I go through this presentation, I'd like you to think about 3 different things, 3 questions you ask yourself. First of all, can you deliver an outstanding employee's experience to your users, regardless if they're local or remote? Can you monitor and observe your workers, regardless of where they're working at? And then what can you do to automate the resolution of issues, to reduce the time to resolve the problem, and do root cause analysis? So kind of keep those in the back of your mind as I go through this presentation. we need to work smarter. We simply can't work harder. Unemployment's at an all-time low. We can't get workers in to resolve issues. So we need to work smarter. Even if we could get employees in, it takes 6 months, a year for someone to come up to speed. There's too much tribal knowledge out there that it takes for people to acquire. So we have to use our resources as wisely as possible. And that doesn't just include our human resources. It also includes our physical resources. During the past year, it's been kind of tough to get servers. It's been tough to get any technology. Chip shortages have affected us, supply chain issues. So we really have to use our resources as wisely as we can. And I have a saying I like to tell people, a wise man learns from his own mistakes. A rich man learns from others' mistakes. And that's something that we need to do. We need to learn from others' mistakes, others' people's experience. We just don't have the time. We just don't have the resources to make mistakes ourselves and figure out solutions to them. With that said, last 2 years have just been crazy. IDC did a poll, said mobile workers, remote workers will be 60% of the total U.S. workforce in 2 years or so. If you would have asked me 3 years ago, when will remote workers actually become a majority of the workforce? When will this technology actually be embraced and taken off? I would have said maybe 7 to 10 years. But the last 2 years have changed everything. We were forced into a situation, I like to think of it as the largest mass migration of workers ever. We went from working in the office to working in remote locations, and it worked. Companies are actually happy with it. They've done polls. Stanford did a real interesting poll, and 51% of the corporations say, yeah, we're getting the same amount of work, if not more work, from remote workers than we did when we had them in the office. Workers love it. They love the flexibility of living where they want, working where they want to, rather than having to be close to, San Francisco, L.A., Boston. And this has been proven out. When people have the opportunity to work remotely, they kind of left those cities and they went to where their family was, where their recreational choice is. I live in the Pacific Northwest. I go skiing quite a bit. If I had to move to San Francisco, I don't know if I could do it. My family's here. I just don't want to do it. And so this is a trend that we will definitely see continuing. Let's see, what else? So we have workers who are going to work remotely. We need to give them the best experience that we can. We need a strategy to supply these workers with the same amount of resources, the same quality of digital experience they had when they were in the office. So we really need to focus in on that and make sure that they're doing good, because they will leave a job if they aren't satisfied, or if it's frustrating for them to get work done. So I just need to do just a little bit of level setting here and tell you what VDI is. I know the previous session did a kind of an overview here. This is my overview, kind of level set here, what VDI is and why it matters. And like I said, I was really in a unique experience and position when virtual desktops first came out. I was working at VMware when they released their first VDI product, and so I was able to see it grow and mature. And when I first got assigned to doing some course development with it, I didn't get it. Why would you have these remote desktops on virtual machines other than physical machines? And then as I got more acquainted with it, I understood that it can be a cost savings. If you had a large call center, not everyone needed their own PC. You could have virtual desktops in a server, and the numbers actually worked for cost centers. But that was 20 years ago, and servers were kind of expensive. You could maybe have 50 to 70 workers per server, and so the cost savings was a little bit fuzzy, and there were only so many call centers in the world, so it kind of stalled there for a little bit. But then we came up with a new reason for VDI, and that's security. About this same time, you could open up the USA Today. I'm sure you guys all remember this, and you'd see a story about someone left a laptop at a diner, someone left a laptop at a coffee shop, and tens of thousands of Social Security numbers were revealed, and we had to do some remediation to make sure that people weren't compromised through the release of this information. So we sold VDI on this security concept. We said, all the data is where it should be, inside the data center, behind locked doors, and we continued to grow VDI that way. And then a little bit later, we had a massive hurricane that took out office buildings in Manhattan. I'm sure all you guys remember that. And this was in the early 2000s, and we hadn't really kind of wrapped our mind around the fact that the PC was a work device, that we absolutely essentially needed this desktop in order to complete our task. People weren't able to get into Manhattan. And so business continuity is what we sold VDI on. We said, no matter where you're located, you'll still be able to access those resources that you need. So business continuity helped to grow it. And then we also had management. We had charts, calculators that show how much more efficient it is to manage desktops from a central location rather than going out to each individual PC and making corrections. We were able to manage these virtual desktops with a single image and then roll out changes to it on a weekly basis if need be. And so right now we have this convergence of all these factors that are really driving VDI. VDI has exploded in the last 2 years. It's just been fantastic. People are happy, companies are happy, so we're going to continue to see this growth. So what we're looking at here is just the simplest VDI topography that I could come up with. We have the hypervisor servers that publish these virtual desktops. You can have Linux virtual desktops. You can have Windows virtual desktops. And you can just publish applications if you don't want to publish the full desktop as well. We have cloud desktops. You can have these desktops in the cloud. You can connect to Azure desktops. You can connect to have your desktops in Google Cloud. You have a lot of flexibility there. And then one of the more interesting things that I saw at the beginning of the pandemic is media and entertainment. They have these powerful workstations to do editing of all the content that we've consumed over the last 2 years, all the videos that we've seen. But people weren't able to take these workstations home because they were oftentimes shared between three different shifts in a global type environment. So we weren't able to take them home and share them that way. And data locality was also an issue. Movies have these huge files that need to be edited, and over the existing network, it just didn't work well with the data securely locked away in the data center and then streaming it to your home. So these physical workstations, we found that we could also use VDI with them as well. On the end user side, they have clients that can connect to them. You can use mobile devices like tablets, cell phones. You can have bespoken devices like thin clients, or you can just use your home PC and use a native client to connect to these remote resources. And these clients, you can have a wide variety of them. Right here I'm showing the two extremes. ClearCube makes a little VDI client about $150. It's based on the ARM processor, the Raspberry Pi. I think this one uses the Raspberry Pi 3B+. $150. Supports 2 monitors. Works fine for task workers, people who only need an application or 2. On the other end of the spectrum, that's the Amulet hotkey, and it's a powerhouse. It's based on actually the Dell DX3240. Has a 6-core i5 processor in it, 8 gig of RAM, and supports up to 4K UHD displays at 60 hertz. So it really is a powerful system. It's expensive. It's not an inexpensive system. In fact, you could probably buy a basic PC for the same cost. But what this higher-end client can do is it can do video rendering. It has the capacity for the multiple screens. Financial institutions love devices like this because they have a bunch of different screens that they need to do. And again, financial institutions obviously don't want people to work from home and have that data at home, so they need the virtual desktops there as well. And the client seems like a simple device, but actually it has quite sophisticated software in it to make the flow of data run smoothly. It does things like compression. It does things like build from lossless. It detects which pixels have changed and then only will transmit those pixels from the virtual desktop to the client in order to save networking space. So the client software is pretty sophisticated. Not back in the early days when we just used RDP, and for the most part it worked. All right, now that we have a little background, let's go ahead and talk about some best practices and things to look for, and security, things like that. This is showing two different screens. The screen on the left is showing the virtual desktop itself, and the screen on the right is showing the client device. And that's another lesson we learned about 2 years ago, is that the client device and being able to monitor and manage that client device is so important. We found out early in the pandemic that people really didn't have commercial grade routers. They didn't have commercial grade equipment, and it was causing some problems. We didn't really have the tools to monitor those clients. Oftentimes it was a person's personal PC that they were using, and we just didn't have the tools to monitor that. So when people would call in, they'd say, hey, I'm having a poor experience. We tend to go through the things we know. We checked out the virtual desktop. That seems all right. We checked out applications. Those check out right. But we didn't have the visibility to the endpoint device for it. And so we did come up with some techniques and some tools to look at that. Another thing we found out early on is people were working from coffee shops. They were working from different locations connecting to the Wi-Fi router, and these Wi-Fi routers might not be set up correctly for the Wi-Fi authentication that our corporate governance says that we need. And we didn't have a way to really check that because that's all on the client side. So we needed to come up with ways to do that. And so people have invented tools to go out there and run on the client and look at Wi-Fi authentication. And furthermore, they have tools that will shut down a connection if it doesn't have the authentication that is within our corporate governance. I do see a few questions out there. And either I'll answer those questions in real time, sometimes I'll delay to an appropriate time in the presentation, and then, of course, John will do a wrap-up at the end of the presentation and catch all the ones we missed. So thank you for those questions. So we need to make sure that the end user has an ideal user experience, the best user experience that we can give them. There was a recent poll that was taken and identified the biggest issues that users are having, and number one was log-on duration. How long does it take to log on? Company went out there, did a big analysis of log-on durations. They found out that overall 30 seconds is about what it takes to log on to an OS, virtual desktop. And in this case, we see a user that is having a 318-second logon duration from the time that they enter the password to the time they actually get the screen. And so maybe this is unacceptable. A lot of factors that come into it. Maybe there are things that are going on in the background that actually take that long. But we kind of shoot for a community average of about 30 seconds for the logon duration to take place. But we need a way to monitor this. We can't really depend on the end user to report this. We get beaten down as end users. We simply, will not report a problem if it happens all the time. Maybe we called up once and said, hey, it takes a long time for me to log on. The call gets ignored, or, we can't find a reason. So we need a way to, as a tech support, as an organization, to monitor this and notice that we can't depend on the end users. They'll simply, go get a cup of coffee while they wait for it to blow on. So log on duration, we need a way to monitor it. We need a way to see all the different processes that are running during the log on process. There's a bunch of different tools out there that will do it. They'll break it down by process, how long each process is taking to do it, so we can go through and investigate it. And on a security aspect, we need to know what's going on during this. This is one of the ways people kind of sneak viruses in, is during the logon process. They can put a program in there that maybe we don't want them to run, so we need a list of all the stuff that's going on. And the logon process basically has three different phases that it goes through. It does pre-startup, make sure that your password's legitimate. It does the VDI protocol connection, sets that up. Then it goes to the login, brings down your user profiles, group policies, does the login script. And then finally the shell starts and the applications get going. And there's programs, there's things that can analyze this and tell you where you're having problems. You'll notice in the lower right corner here, the group policies in the red box there, that's taken 51 seconds. So maybe we need to take a look at our group policies and see what's going on there and see if we can streamline those. And by the way, I picked group policies because it is one of the things that we see a lot of times that is causing logon durations to be unusually long. Another thing that we had a tough time diagnosing is response times. Till about 3 years ago, we really didn't have a way to measure when a user clicks on an object or enters something to the response back that we get from it. But then about, I want to say 3 years ago, Microsoft came out with something called the max process input delay. They put this metrics out there that actually monitors, the time when someone clicks an item to the time that they get feedback from the item. So this is so important to make sure that our users do have that good digital experience. But it's impractical for us to monitor each desktop using, the performance monitoring. So there's other tools out there that collects this information, aggregates it, and then goes ahead and displays it in on a chart form. And that way you can see when users are having issues. Some of these programs can do automation around that. Like I said, we need to use our resources wisely. So we tend to give virtual desktops, applications, the minimum amount of resources that we can while still ensuring that the user has a good experience. So we can use this information to trigger, and maybe if someone is having an unusually long input delay, we can give that user more CPU power, things like that. So we can do really neat things around automation with that. As a guideline, if a user has to wait more than 1/10 of a second, they start to notice it. If they wait more than a second, you better start to give them some kind of feedback. You better have a clock going, or the little timer going, something like that. And if they have to wait more than 10 seconds, they lose attention. They're going to go on to the next task. Those are some kind of general guidelines there. Now let's start talking about the virtual desktops themselves. definitely a best practice is to use a cloned virtual desktop. And a cloned virtual desktop uses a gold image or a master image, and the virtual desktops themselves are created from this master image. And what this allows us to do is have a master or a gold image that has been thoroughly tested, has had all the security protocols that we need put into it. It can be patched to the latest upgrade and then rolled out to the users. And that way we know that they all have a similar desktop that is secure and does meet our corporate guidance standards. Some companies, some VDI companies are doing some real interesting things with this. They can clone these desktops in mere seconds, which really gives us a lot of flexibility. We can do things like build just-in-time desktops. So every time that a user logs on, they'll get a fresh desktop. So any viruses, any security patches that have been put on the gold image will get flushed down to the users every time they log on. It makes it a very nice, secure desktop for it. What else about these? Yeah, so if you aren't using cloned virtual desktops, you really should be. And like I said, the instant desktops, I think, is kind of the way of the future. They call these composable desktops because it'll go ahead and create the desktop OS and then bring in the applications to them and the data as well. Desktops are good. Desktops have, kind of historically been what people want, but I've seen a lot of interest in using published applications. Published applications have been around for a long time. In the early days, Citrix, they just published the applications, and that just means you're getting the application. You aren't getting the whole desktop. It's very secure because you don't have to worry about the other items that are running on the desktop. These published applications can run on a wide variety of devices, cell phones, tablets. You can run a Windows application on a Linux machine or Windows applications on a Mac machine. You can have a Linux application running on a Windows machine. Just gives you a lot of flexibility. Streamed applications are widely used in healthcare and other verticals that need to deploy applications regardless of where the user's platform or location of the user is having it. Another advantage of published applications is data locality. As I mentioned with the M&E in the early days of the pandemic, we needed to be close to those video resources, those video files. So published applications does the same thing. The application lives close to the data. Let's see. So best practice around published applications. When security is of the utmost importance, a lot of people choose to use published applications. Users really don't need a full desktop. I used to teach at a university, and one of the first things I said is, people want applications. They don't care about the desktop operating system. They don't care about the hardware. We just need to get people applications. And the smaller footprint that we can give them, the smaller the security vulnerabilities are. And a lot of times desktops just don't display well on mobile devices. They're just too large. It has a lot of the taskbar, a lot of stuff that they simply don't need. And I do see a question here that feeds in great to that last question, or the last bullet point there is Windows licensing cost is prohibitive. The question is, why would you use Linux to stream applications? Take, for example, if you have a kiosk with a web browser on it. Linux supports lots of different applications. Web browser is one of them. So you can go ahead and set up and have the a web browser just streamed from that Linux machine. It's going to save you a lot in licensing costs. Also, you can stream Windows 10 applications. Windows 10 has the ability to stream applications as well. And for applications that use UWP, Universal Windows Platform, that won't work on Windows Server, you can use Windows 10 with them. Also, maybe you have a .NET application that Windows Servers doesn't support. Or some applications have doggles or additional drivers that simply don't work on Windows servers. So you can stream Windows 10 applications as well. One of the things that we found during the early days of the pandemic, we were using a lot of unified communication platforms, things like Skype, Zoom, Meet, and we're using a UC right now. And these kind of hammered the virtual desktops. They tend to be very CPU and network intensive. So most VDI vendors came up with techniques to offload that. Right now you're looking at a virtual desktop that is running Zoom. It's consuming 50% of the CPU on that virtual desktop. You remember these virtual desktops are being hosted in data center using enterprise-grade servers that tend to be very expensive. And so when you run something that is CPU intensive, it minimizes the number of virtual desktops you can have on each server. That's called guest density, how many virtual desktops or how many desktops or virtual machines you can have on each server. And we found that we were kind of running short on resources, so we started to use things like multimedia redirection. And what multimedia redirection does is it takes that process, in this case it's the Zoom process, and instead of running it on the server side, it actually uses the excess capacity on the client side to run that process. And you have to realize in the last 5 years, the price per processor has dropped so much that in these clients, these native clients, these thin clients, we have excess CPU capacity. The box on the lower left shows how much unused capacity is on that client. This is a screenshot from a client. And we're using maybe 5-10% of the CPU capacity. And so what we do is we take the Zoom process, the media process, and go ahead and run that on the client itself and use the excess capacity on it. So it not only frees up CPU capacity, these MMR, the redirection, it bypasses that network traffic and puts it directly out to the net rather than going back to the data center. Again, we found that the network traffic from UC is very intense, and so anything we can do to offload that works out well. I see another question here. Okay, the question is, other than UC processes, does anything else use redirection? And yeah, a lot of VDI processes or VDI software allows you to do things like set your web browser or your video display to use the capacity on the client rather than the server itself. Thank you for that question. Good question. Oh yeah, that was actually a great segue into this slide where we talk about things like networking and how that gets passed through the physical server if you aren't using some kind of redirection. So, yep. Another thing we found, and one of the things that we found is that people were calling in saying, "Hey, I can't get to my my virtual desktop. I can't get to my published applications. And so they'd call up the help center would say, let me try and recreate the problem. The help desk would be able to, they say, we tried again, and miraculously the end user would be able to connect to the virtual desktop, the SaaS application, what have you. And what we found was happening, that the application would be, the remote application would be down for a little while, and we simply didn't know it, and we gave enough time frame that it came back up. So what we need to do is come up with some kind of synthetic monitoring. There's synthetic monitoring tools out there. They'll go out and probe and make sure that the virtual desktop or the published applications are actually running, and alert help desk if they aren't running, or if they did go down, then the help desk could go say, yeah, you know what, an hour ago this application wasn't available. So this synthetic monitoring goes out there and probes the different applications and makes sure that they are available. I've been using synthetic monitoring for the last year and a half. I have some people that I work with who also use these synthetic monitoring tools, and we found some interesting things. About a year and a half ago, Azure AD went down, and we were aware of it before Microsoft made it general knowledge that it was having some issues. So that was kind of neat, and we actually tweeted about it, that it was having some issues before Microsoft did. Another interesting thing, I have a guy I work with who's based out of Ireland, and he was having some problems with Office 365. And these synthetic monitoring tools, they're usually set up in data centers and in public clouds, so you can have them deployed all over the world. And what he found was that Office 365 wasn't available from some regions in Europe, but they were available in the U.S. So when he contacted me and said, I can't get to it, I was able to get to it and say, yeah, I'm not sure what's going on. We were able to bring up the synthetic monitoring and say, yeah, you know what, it is a geographically issue, depending where you're at, whether you'll be able to get to it or not. So kind of some neat things there that you can use with this synthetic monitoring. And with that said, I am no way bashing SaaS applications or cloud computing. This is over a year and a half, and I have maybe 3 examples where it went down and we had some issues. So overall, the reliability is fantastic, but when they do go down, you do need to be aware of it, and you need some kind of historical reference for all this information. So you can go back and talk to your SaaS provider at the end of the year when you talk about SLAs, and you can actually have this information say, yeah, we have 99.8% availability. You promised, 99.9, and here's the information. So these synthetic monitoring tools are kind of neat to use in conversations like that. All right. So kind of at the beginning here, we were talking about home networking and some of the challenges that we had at the start of the pandemic when people started working from home and we didn't have visibility into their end device and compute device, what they were using to connect to these remote assets. And since that time, there's been various programs that have been developed that actually go out there and can do it. This one I really like because it has a small client that runs on the client device, and it goes out there and probes the network router, goes out there and probes the virtual resource that you're getting to, and then it also goes out there and probes a good known IP address. In this case, it's Google. So we can get a real good idea of what's going on. For example, I live outside of Portland. Portland has a lot of old houses with this lath and plaster construction that's basically a Faraday cage. And if you're trying to use your laptop over Wi-Fi to connect to your router, it really depends where you're situated in your house, whether you're going to get through it or not. And it also depends what Wi-Fi protocol, whether you're using 5 gigahertz or 2.5 gigahertz to get to it. So with this information, we can help users that might not be doing things like monitoring their Wi-Fi signal strength. A lot of times, just tell the people to move a little bit closer to their Wi-Fi router, or move the Wi-Fi router out of a closet that has, lath and plaster construction in it. And like I said, this one we're seeing some serious issues. It's latency between the endpoint device and the router is just horrendous, 219 milliseconds. And to the virtual desktop itself is 362 milliseconds. So we do have some other issues going on. Maybe we have kids watching Netflix or doing some gaming that's consuming all the bandwidth. So information like this is invaluable for this remote workforce that we're seeing. We actually talked about this. If you are having problems, or if you have high-value workers that absolutely positively need that access to those remote resources, you can set them up with things like SD-WANs. SD-WANs are really cool. They're usually physical devices that allow you to use a bunch of different transports over either broadband. Some let you use 5G. And so if your broadband goes down, it'll go to 5G. Obviously, 5G is more expensive than broadband, so it only uses that when it absolutely needs to. And so it does this path selection and you can set up policies from a central management console to decide, when things happen. These can also be more secure than just a regular router. They can add other layers of encryption onto it. They can also generate reports for it. So they really are kind of neat ways to ensure that high-value users do get the permissions that they need. Someone's asking about specific vendors for SD-WAN routers. There's a bunch of different router or SD-WAN vendors out there, and a few of them have, in the last year or two, have actually been purchased by other companies. So this is kind of an exciting field, but there are a lot of vendors out there, and some of them have physical SD-WAN routers. Others have virtual SD-WAN routers. And one of the more interesting cases that I've seen is a company that paid for the network activity from the users. They use SD-WAN routers to give priority to the worker rather than the kids trying to play games or who are trying to game or watch Netflix on them. So let's talk about the infrastructure itself. In the early days, we had composed infrastructure that had compute nodes and storage arrays. These were two separate, usually managed by two separate groups. And the problem with this, especially on the storage side, was you had to buy these big, expensive storage arrays. And when you're doing something like VDI, you had all this unused capacity because you didn't want to roll it out, VDI out to all the users at the same time. But the storage arrays you had to buy, and petabyte of storage, what have you. And it was, quite expensive to do, especially when you weren't using that capacity. Another issue that we had was the management of the storage and the compute was done by two different groups, and depending on your corporation, it could take weeks to get a hunk of storage for those new VDI users. And so about 10 years ago, companies like Nutanix, they sponsored this. They came up with a hyper-converged infrastructure where we take these servers, take the storage on the servers, the local storage, and we create a pool of shared storage amongst the different nodes. And by having this shared storage, it has a lot of value because you were able to replicate the storage to different nodes or locations. So if one server went down, the storage was still there, and the VDI a desktop was still available, even if the server that it initially was on went down. And one of the big benefits, and I think probably one of the biggest benefits, is you had a centralized management console. So you were in control of it. You could decide when you wanted to allocate more storage. Another neat benefit, and I think they were talking about this in the previous session, is with the capacity, you could add another server. You didn't have to buy another storage array. You could just buy a single server to add more VDI users. And VDI really is the killer application for HCI or hyperconverged infrastructure because it has such a predictable rollout to it. You know that you can get 50 users, 100 users per server on it. And so when you knew you were going to roll out another 100 users, you just bought another server, made it real easy to architect. And you didn't have this huge CapEx up front. You could, gradually, you could forecast, a quarter in advance rather than 3 years in advance and figure out what kind of devices and servers that you needed. And like I said, Nutanix has just been on the forefront of this technology, has done a really good job with it. So what to look for in HCI? You want an agnostic HCI solution. There's a lot of different VDI software out there. VMware has Horizon, Citrix, LeoStream, and then there's a handful of others. So you want the flexibility to deploy the software that you want. You also want your hardware selection. If you're a Dell, if you're a Lenovo house, you want to kind of probably keep those kind of servers. So you want this software agnostic and hardware agnostic HCI management flexibility. Like I said, you have that central screen where you can manage the software and the hardware. You have to make sure that it's intuitive for you to use. A lot of HCI applications have quality of service. Not all users are equal, and the reality is that we need to make sure that high-value users get the resources before maybe lower value users. Needs to be resilient, needs to be able to fail over and fail back quickly and efficiently. Also things like ecosystem. If the HCI vendors know that they can't be all things to all people. So make sure there's a big ecosystem around it so backup software will run on it. Also, if you can get a trial version or sandbox to play with and make sure that it fits your kind of workflows is important. Cost, I put cost down there at the bottom for a reason because I think manageability and a lot of the other factors are more important than a slight savings in cost. On the storage side, they usually tell you how much usable capacity you have rather than raw capacity because they do things like RAID for redundancy. So take a look at usable capacity versus raw capacity. If they're doing simple mirroring, then you can basically take the raw capacity and chop it in half, and that's how much usable capacity you're going to have. Also things like storage-only nodes. Some HCI vendors, you have to buy an HCI license, which might be more expensive than just a storage-only node. What we found is that sometimes we have more storage that we need. We have more need for storage than we do compute, and so having those storage-only nodes is quite convenient. You want to be able to deploy it quickly, have a faster time to value that way, have a faster ROI if you can deploy it quickly, and if it's a well-known HCI. Also, the ease of increasing capacity. As I mentioned previously, if you need to add another cluster, what's involved with that? A lot of HCI, for example, Nutanix, you pretty much just plug in the additional server and can do it. Also, cloud desktops, we have the ability to use desktops as with these HCI implementations. DAS is great. It can give you a wider geographical performance, a geographical location, but you do need to be aware of your governance rules around using DAS versus on-premise. A lot of HCI implementations and VDI implementations do allow a hybrid model, and that's actually really great. Here's some best practices for VDI, whether you use HCI, DAS, or a hybrid. And I think if you can find something that does the hybrid, really is kind of the way that the future is going, and where people are liking. They like that small CapEx that you get with the HCI, but with DAS, it's a pure OpEx model. And you can purchase DAS as it's used, where with HCI you do have to purchase for the near term. And the clients, whether they use the native clients or the clients or thin clients, just kind of depends on what they want to use and their use cases. Just a couple things why VDIs have failed in the past. They weren't rolled out in phases. So definitely roll them out, a pilot and then group and then department as you get more comfortable with them. So roll them out shortly. I also have to mention I/O storms, simply because they are a misconception that they still happen, and we've pretty much got away from I/O storms. And I/O storm takes place when everyone logs on at the same time, and it kind of used to slam the disks when we had hard drives, but NVMe drives and SSDs have pretty much eliminated that. So if you've heard, how VDI doesn't work because of I/O storms, that's not true. Today's technology really has made those I/O storms a thing of the past. Let's see, talking about that, cost overruns, converged infrastructure when you have to have that huge upfront cost. With HCI, you can roll it out as needed and avoid those cost overruns. Talk just a little bit about management. Skip over this real quick. Make sure you monitor everything. Make sure that end user is having a great end user experience. So monitor. You can't always count on the users to report. Also automate. There is Nutanix has some great automation that you can configure to take place. They have a great example where if a VM is running low on memory, they'll go ahead and take it offline, add more memory to it, and bring it back online, and that's all automated, so you don't need to interact with it. Monitor the entire infrastructure from the end client all the way to the remote applications. And if you follow some best practices, you'll have better security. The end user will have a better experience. You'll be within corporate and government regulations. You'll be able to meet your SLAs. So, like I said, you need to learn from others with regards to best practices. You can't recreate the wheel. You can't recreate other people's issues. And I think that just about wraps it up. Hopefully you kept the 3 questions in mind, whether you can deliver an outstanding, secure employee experience to your users, can you observe it, and can you automate it? And with that said, John, do you have any questions out there? I answered a few.
Yep, you nabbed a few so we've got one here from Mark. I want to maybe squeeze it in because we're just about out of time. So he wonders, any thoughts on best practice for managing security agents, for example, non-persistent VMs / desktops over published apps and having to deal with agent registrations of GUIDs for licenses and management and orchestration consoles?
That is a long question, and I just don't think I have time to give that the credit that it needs. That's an entire topic. I just can't even begin to answer that.
Well, then I'll hit you with one of mine. I don't want to be the guy who asks the dumb question today, but how hard is it to redeploy on a virtual desktop?
It is so simple with today's technology. You just log into the VDI management console, say I wanted to redeploy it, then it gives you the option whether you want to redeploy it instantly. Maybe you have a security issue that needs to be addressed instantly, and it'll log those users off and deploy the new image, and then they'll be able to log back on. Or you can say, you know what, as soon as they log off, that's when we'll give them a new desktop. So it's easy peasy to do that.
Easy peasy. All right. Well, that's good to know. I know that is our time. Before I forget, so congrats on the new book. And what is, remind us of the title? ESXi on ARM. And I show you how to deploy a ESXi server hypervisor on a $75 ESXi ARM Raspberry Pi. Where can people get it?
They can get it from Amazon, Barnes & Noble. They can go to A-Press. And I do have to give a shout out. All the proceeds of the book are going to the Mountain Hoods Kiwanis Camp for disabled children. So you're supporting a good cause there, too.
It's awesome, man. All right. Thank you very much. Thanks for a great presentation. Many thanks to Tom Fenton for this great presentation, and to our sponsor, Nutanix, for making it possible. We are going to take a short break, a very short break, but we will be back at the top of the hour for our third session, Securing the Remote Workplace, which will be moderated by Becky Nagel, Vice President of Web and Digital Strategy in the Converge 360 group of 1105 Media. Now would be a great time to check out those extra resources on your console.